Alright guys, right now we're going to move on to chapter 2, which is essentially coordinate geometry. Coordinate geometry, right? And what we're essentially going to be talking about over here is the t-axis. Now, the t-axis is something that can determine both the x-axis and the y-axis. Essentially, it can define both x and y, as you can see right over here. You'll see that x is equal to 2t and y is equal to t squared. So, if we have the t values, we can calculate both the x and the y values, as you can see over here. You can calculate the x and the y, and you can see it plotted all the way over here. Alright? Now, in essence, this is really very simple. It just comes down to basic geometry, really. The first thing that you're going to be told to calculate is the Cartesian equation. What we mean by the Cartesian equation is essentially y is equal to something involving x. Basically, a Cartesian equation is an equation that involves only x and y. Now, an example of this conversion would be something like this. Alright, so you have x is equal to t minus 2 and y is equal to t squared. Alright, now we're going to have to simply come up with a Cartesian equation, which means an equation simply involving x and y. I just put y and x here, but you know, x and y, y and x is the same thing. Okay, so we can see here that x is equal to t minus 2 and y is equal to t squared. The first thing we're going to have to do is find the value of t in terms of x or y, whichever is easier. Alright? So here we can see x is equal to t minus 2 and y is equal to t squared. We'll just try to find t in terms of x because you can pretty easily calculate that, alright? Okay, so back to this. So x is equal to t minus 2, alright? So t is equal to x plus 2. Okay, so now we have the value of t in terms of x. Alright, all we do now is use the y to calculate what we use the x and the y now. You see, the y is essentially equal to y is equal to t squared. So t is equal to x plus 2, so y is equal to x plus 2 squared. It's really that simple. And that is your answer. Yeah? That's really the first type. Moving on to something a little bit more complicated. That is x is equal to 1 over t plus 1 and y is equal to 1 over t minus 2. essentially you could start with either x or y here. You could start with this or this, because they're pretty much the same when it comes to complication, that is. So, I have a tendency to start with x all the time, so I'll do that. So x is equal to 1 over t plus 1, right? So x t plus 1 is equal to 1. Alright, so xt plus x is equal to 1. Now simply, what we do here is this. We continue the equation. So xt plus x is equal to 1. We need to find everything in terms of t. So we will simply take x here and just put t plus 1 is equal to 1. So t plus 1 is equal to 1 over x, because the x, if we divide both sides by x, the x will become the denominator of 1. So what we get here is something like this. T is equal to 1 over x plus 1. That's it. That's really it. So right now we found the value of t in terms of x. All we gotta do now is put this value that we just received for t over here. We just replace this t with this, and we'll get our answer. Continuing that, so y is equal to 1 over t minus 2. So y is equal to, using the value of x, 1 over x plus 1 minus 2. Alright? Y therefore is equal to 1 over x plus 1 minus 2. Y is equal to 1 over x minus 1. Alright? So, yeah, you could just finish it off as y is equal to 1 over x minus 1 to the power of negative 1. It's really that simple. I mean, this is how I'd write it, because you could simply put it in a calculator and it would be just easier to calculate. I just prefer it like this. So yeah, you could write it like that. Or you could also write it something like, wait, I'll just make a little space over here. You could write it as y is equal to x to the power of negative 1 minus 1 to the power of negative 1. And that would be your answer. So that's the second type you'll get, and really that's the most complicated it can get when it comes to finding Cartesian coordinates. Okay, so the third type of problem that you're going to get is finding out the x and y intercept from an equation involving t, alright, which is essentially the third dimension in any problem. So right now we have a little problem here. X is equal to 2t plus 1 and y is equal to 2t minus 6. What we're going to have to do is find the x, where the curve meets the x-axis. Now, if the curve is meant to meet the x-axis, then that must mean that the value for y is 0. So the Cartesian coordinates would be something like x 0. Alright? Okay. Let's get on with the problem then. So x is equal to 2t plus 1, y is equal to 2t minus 6. We are going to essentially have to equate this into a Cartesian coordinate into a Cartesian equation. So first, the process of turning this into a Cartesian equation. Alright, so how do we do that? Well, remember the last time we did it, we just calculated the value of t of x in terms of t. Or I mean the value of t in terms of x. Sorry. So the value of t in terms of x. So we just calculate it here now. X is equal to 2t plus 1. X minus 1 over 2 is equal to t. Alright? Now we just substitute it here. Okay then. So y is equal to x minus 1 over 2 minus 6. Now remember, y is 0 because remember, because we are looking for x-intercept. Alright, because we're looking for the x-intercept. So that just means we have 0, 0 plus 6, because the 6 will move on to here and it will become a plus, because y plus 6 is equal to x minus 1 over 2 minus 6 plus 6, and that means the 6 will cancel out. So 6 over here, sorry, is equal to x minus 1 over 2. So 6 times 2 is equal to x minus 1. 13 is equal to x. Therefore, the place where the intercept happens is essentially 13, 0. Alright? That's really it.